So my sincere hope is that this video is actually all a review. My hope is that all of you actually remember Pascal's triangle, and that you also remember the combinatorial coefficient, which is basically NCR. And so if you're looking at that, thinking about that, and going, yeah, I remember all this, you might just want to skip to the second video in the sequence and make sure you can do that, or skip to the example at the end of this video and see if that makes sense to you. But if you know you've forgotten Pascal's triangle and what the heck that NCR thing was, then this video is really for you. So let's start by constructing Pascal's triangle. Pascal's triangle is this triangular shape of numbers. It starts up at the top with a 1, right? And each subsequent row after that is going to be one number longer, so you've got like 1, 1 for your next row. So notice that this top one only had one number, this next one had 2 numbers in it. So the next one down is going to have 3 numbers in it. You always have 1s on the outside, and then on the inside you add up the 2 numbers above them, so 1 and 1 will give you 2 here. Right? For the next row down, you have 1s sort of on the outside. And again, remember the idea is that if there were 3 numbers here, there will be 1, 2, 3, 4 numbers here. And these 2 numbers you'll get by adding up the 2 things above them. So you'll have a 3 here and a 3 here. So I mean, think for a minute about what the next row down is going to be. All right, we should have a 1 over on this side. Can I write it there? 1. And then 4, 6, 4, 1. And that's Pascal's triangle. You can continue that on forever, right? This next one down, you're going to have 1, 5, 10, 10, 5, and I don't think it'll let me fit a 1 over there on the side of my screen. There we go, got one in there. Great, so wonderful, that's Pascal's triangle. What we're going to use that for is going to come up in the next video. I'm just reminding you of what it is. Now, what does the combinatorial coefficient have to do with all of this? What it has to do with it is well, first of all, let's talk about computing it. If someone asked you for 7C2, the formula is that it's 7 factorial over 7 minus 2 factorial times 2 factorial. So this ends up being 7 factorial over 5 factorial times 2 factorial. And then if you sort of think about what that represents, this is 7, 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1, 2, 1. So what you notice is that, like they both have a 5 and a 4 and a 3 and a 2 and a 1. Basically that the 5 factorial will remove most of the 7 factorial. And then the 2 and the 1, this 2 will drop the 6 down to a 3. And in short, this is going to end up being 21, 7 times 3. So 7C2 is 21. So just to make sure that you've got that idea, let me give you a couple of these to sort of try on your own. Go ahead and compute 5C0, 5C1, and 5C2 on your own. So pause the video, do these computations, and see what you get for 5C0, 5C1, and 5C2. In case you need some help walking through that, 5C0 should be 5 factorial over 0 factorial, 5 factorial. This one's going to be 5 factorial over 1 factorial, 4 factorial. And this last one is 5 factorial over 2 factorial, 3 factorial. So again, if you haven't actually computed those, please take a minute and compute them now. And I'm going to skip over the simplifying part. 5C0 ends up being 1, 5C1 ends up being 5, and 5C2 ends up being 10. And what you're supposed to notice here is you're supposed to notice or remember or recall or whatever it may be that, hey, check it out. The first, if you think about this being the 5th row of Pascal's triangle, by the way, that may be bothersome to you because you're like, wait, isn't that the 6th row? I always look at the top row and think about this as being the 0th row. And I do that because it's not even really a row. It's like one number. I consider this to really be the first row that's actually a row. This is the 2nd row. This one here is the 3rd row. This is the 4th row. That also makes it nice because you can see right here, this is the 2nd row, 3rd row, 4th row, 5th row. So, coming back down to this, 5C0 is the 0th number in the 5th row. 5C1 is the next number in the 5th row. 5C2 is the next number in the 5th row. Which means this number here is almost certainly 5C3. This is 5C4, and this last one here is 5C5. Right? So all I'm getting at here is the idea that all of the numbers in Pascal's triangle can also be interpreted as this combinatorial coefficient. Right? So as just sort of a quick example of that, suppose that we jump down to the 8th row. Right? The 8th row is going to begin 1, 8, because they all start that way. Then how could we figure out what the next number here would be? Okay. Well, the idea is this first number here should be represented as what? It should be 8C, and everybody's hopefully talking to their computer screen or thinking it in your head. It's 8C0. Okay. This next guy here is 8C1, which means this next one is 8C2. And what is that? Well, it's 8 factorial over 8 minus 2 is 6 factorial times 2 factorial. I just realized, by the way, that all of these up here I had written backward, but it doesn't matter the order that you do them in, so sorry if that was confusing. If we simplify this down, you're going to get 8 times 7 over 2, which is, let's see, that'll drop down to a 4, so that's 28. Great, so the next number over in Pascal's triangle is a 28. Okay. In the next slide, I have one more example of those for you to try on your own, so we'll get to that, and then we'll get into what we actually use this stuff for. Alright, so the 10th row of Pascal's triangle begins 1, 10, so you know you've got 1, 10. My question is, what are the next two numbers in Pascal's triangle? Okay. So first take a minute and write down at least what the combinatorial coefficients for those should be, and then pause the video and compute them for yourselves to make sure that you've got that. So this one here should be 10C, well this was 10C0, this was 10C1, so this will be 10C2. And this other one is going to be 10C3. So when we compute those, 10 factorial over 2 factorial, 8 factorial. Again, I wrote that backward. I think according to what I told you guys on the other side, this should be 8 factorial, 2 factorial. So it'll be 10 times 9 over 2, which is 45. And then for the other one, I'm going to have 10 factorial over 7 factorial, 3 factorial. That's 10, 9, 8 over 3 times 2. Here I'll cancel the 3 with the 9 and the 2 with the 8. So that looks to me like 120. Great, so the next number over is 120. Okay. That's all I have for this video. In the next one, again, we're talking about how we're going to use this stuff.